So a little bit of introduction. I think Ilya gave you a little bit of an introduction, but my name is Dave Cramer. I work for OpenSCG, supporting Postgres, mostly in the United States. I've been the maintainer of the JDBC driver since about 1999, so quite a while. I've been sort of on and off on it, but currently more on than off. Over the years, people have contributed features to the driver, and they've added options for connecting to the driver to enable or disable these features. Many of them I didn't totally understand, so one of the best ways to understand something is to teach it, so I thought I would do a talk about it. So hopefully I'm going to go over some of the more interesting ones and hopefully explain how they work. First of all, is everybody using the driver, using Postgres, using Java? Most people are Java people. Very good. So a little bit of what we're going to do, history of the driver, connecting to the driver, some of the things people don't use and should be using, some performance tips of how to get the most out of the driver, and some major releases that we've done. So originally it was written in 1997 for JDBC 1.2 by a guy named Peter Mount. It was very simple at that point. And then, as you can see, through the years, it's added features for Java 1.1 through Java 9. The most interesting thing about this is that during all these times, we supported, at any given point, we support 3 versions of the JDK, which makes things a little difficult for writing code and releasing code. So let's get right into connecting to the server and how that's done and the various ways that you can connect to the server. So you can see that we have various URL options. This is the connection string that you use. The first one is just a simple JDBC PostgreSQL, gives the URL, and by default connects to port 5432 in the database specified in the user properties. The rest of them are pretty much the same except for the last one, which is more interesting. You can see the last one actually allows you to connect to more than one host. So you can see you can actually have host 1 through host n, and it will attempt to connect to multiple hosts at the same time. Well, it'll round robin connect to hosts. And we'll get into a little bit more detail about how that actually works in a few more slides. There are a number of connection properties that we can use. So the first one being PG_DB name, DB host, and DB port. Interesting enough, before these don't actually work. I found out today, or actually over the week, in my discovery that they're not documented in the driver, and they didn't actually work. I actually pushed a PR this morning that hopefully will enable them. But essentially they can be used in the first connection parameter, or the first connection URL there to specify which database you want to connect to, which host you want to connect to, and which port. These are relatively simple, and we'll get into some more complicated ones shortly. One of the major features that we added recently was the ability to use Java utility.logging. And we have the ability to turn on logging for the driver. You have 3 options. The default is we don't log anything, but now you have the ability to turn on logging for debug and for trace. So if you turn it on, if you set logger level equal to debug, it sets it to the logging utility fine, and trace is equal to finest. We don't actually log SQL in this. And I actually think that's a bit of a shortcoming, and I'd like to figure out how to solve that. But this is more for debugging the driver and seeing what we actually send back and forth in the protocol and how we connect, et cetera. You can also, the other parameter that you can use when you connect is the logger file, and it will set a file name to which you log out to. The default is to log out to the console. There's a couple of functions in the JDBC spec which are driver manager.setLogStream or driver manager.setLogWriter. We actually will still honor those if you call them, and we'll send the logging out to there. The other interesting thing here is, since we're now using Java util.logging, if you're using something like WebSphere or Tomcat, you can configure logging in the properties file for those app servers. So this last one is logging unclosed connections. You have the ability now to provide a parameter to the connection to, say, log unclosed connections. And this gives you the ability to find places where you're not closing connections and connection leaks. What actually happens is we track connection opening, and if the finalizer is ever called, we will print out a stack trace message showing that the connection was not closed and you've got a connection leak. Any questions about logging? Pretty straightforward stuff. Some of these are pretty boring, but they're still there and probably unused. The driver also has a connection parameter called autosave. Postgres is somewhat different than a couple of other databases in that the Postgres transaction semantics are all or nothing. So if a transaction fails, the entire transaction rolls back. We had a number of complaints, issues, whatever, on the JDBC mailing list saying that this isn't the way they wanted transactions to work. They wanted to be able to commit something and, well, commit two things and have the first one persist. So so somebody added in the ability to have autosave equals always, which means that we would create a save point for each transaction, and if one of the transactions failed, the first one would still persist. So in this case, if you inserted into invoice header, inserted into invoice line item in the same transaction, if the invoice line item failed, the header would still be in the database, which is a little different than Postgres normal transactions. There's another connection parameter called binary transfer, which allows you to change which data types are transferred over the wire in binary mode or in text mode. Currently, the driver supports almost all the built-in types in binary mode under certain circumstances, which I'll talk about in a couple more slides. There's another connection parameter called prefer query mode. The driver, in Postgres, there are a couple of different query modes. One of them is extended, and one of them is simple. The extended protocol does a couple of extra steps for, such as parsing, binding, and executing. And the simple mode just does a query and gets a response. So by default, the driver prefers extended mode, and it actually creates a server-prepared statement and uses parse, bind, and execute. There's two big advantages to this. The one is that SQL injection is not possible using a prepared statement, and it's possible to actually reuse a statement. So the one by default we use is called extended, but you can actually specify simple. And this is actually required for certain features that we have in the driver, such as replication. We will talk about replication in a couple more slides. The other query mode that's possible is something called extended for prepared. And this is something that's currently not the default, but I would like to actually explore some benchmarks on, because what actually happens here is that instead of using extended for everything, we're going to use extended only for prepared statements. So if you say connection.prepare statement as opposed to connection.statement, you'll get a simple query mode for statements and a extended query mode for prepared statements. In some cases, I think that would be a lot quicker, but I think it's more dependent on the workload. And then extended cache everything. Currently, the driver has a prepared statement cache and a statement cache. And we don't actually cache simple statements, but this particular mode would cache everything.
Sorry, what are
We internally cache on the client the prepared statement.
Okay. You have like a hash table.
Yeah, we have a hash table. But we don't currently cache statements. We just cache prepared statements.
Is it possible to combine, on the previous slide, combine two last two options to cache everything instead of prepare?
Currently, no. In fact, nobody's actually, the interesting thing is I don't think a lot of people actually use these things because they're not well documented, and I'm kind of trying to get that out, that there are these connection parameters, and so I don't think it's not possible to do that. I guess the question is, why would you want to do it? There's another connection parameter that can be used, which is called default row fetch size. So in Postgres, the default is 0, and which means fetch all the rows. So if you did something like select asterisk from very, very large table, which is 10 million rows, and it was quite wide, the result can be sometimes quite surprising and actually result in out-of-memory errors. And we've seen this on the mailing list where people say, I just ran out of memory, and typically they have a big table or a big data, and they did a query, and they've got all the data, and they tried to get all their data all at once. And of course, they ran out of memory, and they're kind of going, how do I fix this? So we can actually control this and set it to something other than 0. So set it to 1,000 or 10,000, something like that. The only catch is that because of the way it's implemented in the driver, you have to have auto commit equals false. So you have to be in a transaction for this to occur. But as I'll show you later, there's a potentially significant performance boost to being if you use this. This is an interesting one, which predates a couple of versions. I think it was 9.4 or 9.3. But you can tell the driver what type you're going to use for strings. And by default, it's varchar, which means a string really is a string. In previous versions of Postgres, you could have used something like set string 1, 2, 3, 4 to actually set an integer column. That was somewhat removed in previous versions, but if you set it to unspecified, the backend will attempt to infer the type that you're trying to use. So this is really for a legacy application that hasn't been written specifically for Postgres, or is poorly written and uses set string 1, 2, 3, 4 to set an integer column, and expects the server to cast 1, 2, 3, 4 into an integer for you. Application name equals string, another underused connection parameter. It's for servers greater than 9.0. The big advantage is that if you you can actually see in your logs which application actually created the query that's in your log. Currently, I thought I said this. I didn't, okay. By default, it sets it to PostgreSQL JDBC driver. So if you're looking at PG underscore, does everybody know what PG underscore stat activity is? Ever heard of it? Okay, there's one person, good. If you're looking at your server's activity, there's a way to do this in PG admin, for instance. It can show you what's currently running, and it'll show you the query, it'll show you the current process ID, et cetera. And one of the things it'll actually show you is the application name. Now, this is useful if you've got 100 different queries running at the same time to know that this particular application is what's running this particular query. So you can filter on the application name. It's a mundane connection parameter, but it's useful for logging. Another connection parameter that I found interesting was read-only equals Boolean. You can set the connection to read-only. And the default, of course, is false, so you can read and write normally. But what ends up happening is when you set it to read-only, when the connection starts, it will set the session characteristics as transaction read-only. And this will block any writes to persistent tables. What I did find interesting was you can still write to a temporary table. So you can actually create a temporary table even though it's a read-only connection. Disable column sanitizer. That's an interesting one. By default, Postgres folds cases to lowercase. So if you create a column which is an uppercase name, for instance, then it will actually create a column which is in lowercase. If you create a column that is mixed case, and then it will create it in lowercase. There is a way to force Postgres to create mixed case columns. If you double quote them when you create them, they'll be mixed case. pgadmin is actually famous for this. If you type it in mixed case, it will actually create the column in mixed case. So what the driver does is attempts to help you by folding all the columns in the result set to lowercase. So if you try to find something like first name, like I've got there, it's mixed case, you can actually use result set get in first name to get the column, and this will magically work for you. But if you really wanted to get a mixed case column, you would have to set dcolumn sanitizer equals false, or equals true, sorry, to turn it off. Questions about that? There's sort of a lot of information there. Everybody understands that Postgres is lowercase? Okay. Assume minimum server version equals string. There's sort of only two use cases for this. One is the most important one is in 9.4. It's necessary to create replication connections. I have a few slides later on which explain exactly how this works. This is more to enable features in future versions of Postgres. One of which I can see happening is in Postgres 10. I'm not sure who is in the Scram talk by Heikki, but Scram is going to be available in Postgres 10. So we'll be able to enable or disable Scram authentication using assume minimum version equals version 10, and that will turn on Scram for us in the driver. But it'll be useful for other future enhancements in the driver or in the server that we haven't anticipated yet. Current schema equals string. By default, the current schema in Postgres is public. If you want to refer to a table in a different schema, you have to actually qualify it using schema.table. If you set this connection property to another name, it will default to that schema. So if you wanted to change the connection property schema to audit, for instance, instead of using select asterisk from audit.log, you could just say select asterisk from log, and it would automatically get it from the schema audit. So finally, some interesting ones that are more related to performance. Rewrite batch inserts equals true. This enables the driver to optimize batch inserts by changing multiple insert statements into one insert statement. So how is that possible? It's possible if you see the third line, you can actually insert multiple values into a table using one statement. And currently, if you turn this on and you execute batches, under the covers, Postgres will turn your batch into your insert batches into one statement with multiple values. And then there's a couple slides in the future that are coming up to show you the actual performance benefit of that. We have some problems with this, actually. Around 9.5, Postgres added something called onConflict, and we don't handle that very well because you could have you could have a different onConflict for each batch insert, and we don't know how to deal with that at all. So currently an outstanding feature degradation, I'm going to call it, as opposed to a bug.
I'm sorry, was it added because there are ORMs that generate multiple inserts, or what was the reason to implement it?
The current way that we do batch inserts is So everybody understand what a execute batch actually does? You create a statement, you do insert batch, insert batch, insert batch, insert batch, and then you call execute batch. And currently, before this, what the driver did was it actually looped through all the things that you'd put in the batch and inserted them one by one.
Oh, I see.
Okay? So then somebody said, oh, well, this could be optimized to something much quicker, so let's try to rewrite it into a single statement, which obviously is much faster. Because the back end does not support batch statements.
Because I got an impression that JDBC writes it somehow transparently for user. I write the insert into values, and JDBC somehow behaves smart and rewrites it.
So the question was, or the assumption was that there was some kind of magic that occurred in the driver that when we did this, and that is what happens now if you turn on rewrite batched inserts. We will rewrite it, but as I said, we have some issues with rewriting it. I think there's a couple issues with rewriting it. One is returning, and the other one is for on conflict. Previously, we talked about something called connection failover. It's possible to specify multiple hosts in a connection string. You can say, obviously host 1, port 1, host 2, port 2, and then the database you want to connect to. By default, this will attempt to make connections to each host until it succeeds. This is useful for things like where you have a replication, you have a master and multiple standbys, or PostgreSQL, for instance. So, and there's some ways to tune this, which we'll talk about. Additionally to the connection failover, once you specify multiple hosts in your connection string, then these particular options become enabled. And one of them is target server type. You can specify that you want your connection to connect to a master or a slave or prefer slave. So what happens is the driver will query the server and find out if it allows reads or writes. If it allows writes, then it assumes it's a master. If it only allows reads, it assumes it's a slave. And then so if in the connection string you say target server type equals slave, it will only connect to a read-only slave. Does that make sense? Any questions about that? Load balance hosts, by default, the connection will be in the order that they're given. If you say load balance host, it will start a random selection for you. And then host recheck seconds is the number of seconds between checking the status of the host to see whether it's a read or a write, or a master or a slave. The default is 10 seconds.
When does it happen exactly? Not during the connection time?
Sorry?
When do you check the status? On connection? Or
So when we first connect, we'll query the host to find out if it's a master or slave, right?
Okay.
And then every 10 seconds after that, we check again. Because if you fail over, then we're going to, you may change your status, right?
Yeah, but will connection survive the fail?
The connection will, well, define survive for me. It's not going to be, if it reconnects to another host, a lot of things are not going to be the same. The connection will be there, but you'll have to, restart some things, right? It will still connect, but you may have to get your statements again and everything else. So this replication equals database. For one of the exciting new features that I'm going to talk about later is called logical replication. And this particular connection parameter is required in order to get a replication connection. And we'll talk about that later on. But essentially what this does is when you say replication equals database, it tells the backend to go into wall sender mode. You have to use simple query mode, as I talked to earlier. And as I said, it must be accompanied by the assume minimum version equals 9.4 and query mode equals simple. So those are some of the more, what I thought were interesting connection parameters. Are there any questions about those before I go into sort of some of the performance observations of other things?
I mean, is it really used as a replication like that?
Is it really used?
Yeah.
Absolutely. It's an awesome feature. Do you know what change data capture is? So now you can do change data capture right in the driver. I'll show you how in the last few slides show you exactly how to do it. So we're going to talk about a little bit of the performance analysis of what happens if you use set fetch size or rewrite batch inserts. This is the test that we use to do set fetch size performance. It really just selects a large number of, it's actually 10 million rows from a table. The other thing that's important here is I talked about earlier, you have to turn it into transaction mode. You have to turn auto commit off. And then at the last thing you can see that I set default fetch row size equal to various numbers, and we do some analysis of how quickly it returned. So it's just a very simple select statement, and then is everybody familiar with what JMH is? It's the ability to measure performance through Java, and so the black hole consume is just so that the Java virtual machine doesn't optimize the result set get string out. Otherwise, it might just say, you're not doing anything with the result set, so we won't even execute it. So blackhole.consume forces it to execute that. So here's the results. Anything sort of below 100 takes a lot longer to get the data than anything above 100. So if you set fetch size to around 100 is the magic number. This is the time it takes to fetch 1 million rows. So you can see that setting fetch size is fairly important if you're fetching a lot of data. And as I mentioned earlier, one of the bigger things is if you're fetching 1 million rows and you run out of memory, there really is no other way to deal with this other than making sure that you set fetch size. So then the insert problem. As I said, what are the options for inserting a lot of data? You can just loop over your data, inserting each row one at a time until you're done. For each row insert batch, this would be ideal, but as I said, it's really not a whole lot different than inserting each row using insert execute. Then you can use this mechanism which I showed earlier, which is insert into the table and hand roll this code. Or you can use the copy protocol from Postgres. Postgres has the ability to use copy. The driver supports copy, and it's a fast way to put in data in. Again, we have a micro benchmark suite for this. The table is very simple. It has an integer, text, and another integer. So for inserting the batch one row at a time, for each row, just insert the data into the table. And the other way, as I said, this is the hand-rolled way to do this. For each row, insert into the data, but we insert multiple rows at a time by using this trick of putting in multiple values for each row. What ends up happening is you get more data inserted per statement and less statements are executed, so it's much faster. And then insert rewrite, basically the same thing as the last slide, except that the driver does it for you. So we optimize this for you in the driver. And copy just copies the data in. What ends up happening is you have to build a string in memory. The string there shows you the second line, shows you what the string looks like. It's just a 0 is the first integer, the text is the second value, and 0 is the last integer. And then there's a backslash t or backslash to demarcate the end of that. And then we use the copy API inside the driver to insert it. Here's the results. So the slowest way is, actually it doesn't look like the slowest way is right. Insert batch without using rewrite is the slowest mechanism. And then the next one is doing inserts, plain inserts, and copy. So plain inserts are much slower, so using insert batch is a better way to go. Different batch sizes show different values. Insert batch is again the slowest way to go, but you can see that using insert rewrite, which is the red one, which is kind of like the lowest one at the bottom, is the fastest way to go. Any questions about that?
What is this gray bar?
That's a good question. I think that's the insert.
I mean, if it's copy, I don't believe that this is.
It looks like it's copied, but that doesn't make much sense.
Yeah, I'm a little confused with the slide myself. When I copied it in here, apparently it changed the numbers.
Can you go to the previous one?
Insert batch without turning on rewrite is the blue one. And copy is much faster, and then insert. Actually, it should be, I have a feeling that the blue one is inserts. And then insert rewrite, insert batch should be the green one, and then copy should be the fastest.
Any plans to actually do some sort of rewrite into the copy interface?
Into the copy API?
Yeah.
No.
Regular inserts into copy.
Sorry?
Like rewrite regular inserts into copy.
No. There's no plans to do that, but you're welcome to try it. Why would, no, there's no plans to do that. Sorry about these slides. I did these last night, and there was some challenges with the recording equipment here, wanting to install software on my computer that I didn't want to allow them to do. So one of the things about JDBC, which is unfortunately typical, how people use it, they typically open a connection, they do something, and then they close the connection. And without a connection pool, this is a very expensive way to do things. It does not take advantage of any caching. And one of the things that's a little unusual with Postgres is opening a connection is a fairly heavyweight process. So opening lots of connections and closing lots of connections takes a considerable amount of time. And with Scram, that's going to make things even worse. The Scram protocol is going to increase the connection time more than it is now. We don't know what that number is yet, but it will be worse. So a better solution to the previous one is open a connection, prepare the statement, and then use it over and over again. One of the things the driver does that is sort of under the covers and not well explained is that if you reuse a connection 5 times by default, we will change that connection into a real prepared connection on the server side. The difference is that, excuse me, by default, so there's something in Postgres called an unnamed statement, and by default, the driver uses unnamed statements. So when you do prepare statement and you do the execute of the statement, what ends up happening is that we use the unnamed statement, we do a parse, we parse the statement, we bind the variables, and we execute the statement. But we don't switch to binary mode. Okay, so that's very important. In non-binary mode, everything is sent over the wire in text. So integers are sent over as text, dates are sent over as text, varchars, of course, are sent over as text, and everything that comes back is sent over in text. After you execute the same statement 5 times by default, you can change this number, but 5 times is what we've set it to by default. We will say, okay, this guy really wants to use this over and over again, so we're going to create a server-prepared statement, and we'll name it, and we're going to get we're going to do an extra step called describe. So we will know what the types are that are coming back. We'll switch into binary mode, and then after the 5th time, everything will go back and forth in binary mode. Okay? You can change that number to 0 if you like, or 1, so that the first time it's reused, it'll be switch over to binary mode. The reason that we decided to do this is because if you're not reusing the statement, we do not want to take the extra time to do the describe to find out what the types are to switch over to binary mode. Make sense? The query cache, one of the things about the query cache is we don't cache generated queries. So if you aren't using prepared statements, we won't cache them. So if you're using just, you prepare your own statement by generating it in a string, we're not going to cache that stuff. The other gotcha here is on the 4th point here is if you change the type of the parameter halfway through by using set null, for instance, we're going to deallocate the statement on you. So keep the parameters the same types. How much time do I have left? Does anybody know how much time I have left? 14 minutes? Okay, sorry. Okay. So as I said earlier, I'm just going to go over these again. Server prepared is activated after 5 executions. You can change this number. It's pretty well tested that 5 is a decent number. You can use prepare threshold to change the number. And after 5 executions, we'll change from unnamed to name statements. Change to binary mode. It does get quicker. So if you are repeating your statements over and over again, you will get some benefit out of this. Set fetch size. Make sure your fetch size is above 100. You have to be in transaction mode. In other words, auto commit has to be off. If you're trying to read a lot of data, this is really the only way to do it. And I'm going to move to here. So some of you may or may not have noticed, if you've been following the driver, we all of a sudden changed the name, the numbering type for the driver to 42.0.0. And the reason we did this was because there was a lot of confusion as to which driver they should use for which version of Postgres. So people were using Postgres 9.4, and they're saying, well, we have to use the driver version that had 9.4 in it. Well, that wasn't true. The version that you should be using at any given time is the latest version that we produce, regardless of the server that you're using. So we wanted to divorce ourselves completely from the server number, so we chose the number 42. It was more or less at random, but it's also the answer to the question. We had to pick a number. It was as good as any. And we expect that it'll be somebody else's problem when Postgres 4.42 comes out. It's currently at 10. So I hope not to be maintaining the driver when that happens. So notable changes, we actually dropped support for versions below 8.2. We changed to Java util.logging. And the most exciting feature is the replication protocol API was added, which we're going to talk about. Is everybody familiar with what logical replication does, how it works, why you'd ever want it? Anybody? Everybody? Okay, we have 1 person, 2 people that know 3 that know what it is. I should have 2 more. Okay, so logical replication allows you to replicate data from one database, a single database inside Postgres, to basically any format that you want using a plugin. And the plugin is a piece of C code that takes the changes that occur in that database and outputs it in a format that you create. It could be text, it could be JSON, it could be XML, it could be the latest lingua franca, whatever that might be. The interesting thing is it only sends changes in the database. They have to be committed to the database and written to it. Thank you. So logical replication. So the advantage for this is, how do you capture changes in your database inside your Java code in real time? Previously, what people used to do was they used to write a thread. The thread would sit there and select on a table that they were interested in, watching for changes. And if your application were to die halfway through, you might miss a change. The way that logical replication does this, the information is stored on the server. The server takes care of this. You cannot miss a change as long as you do logical replication correctly. And this is a quick overview. It's not complete by any means, but the steps of doing replication is to create a replication connection. We talked about that earlier. You have to specify replication equals database. You have to say that you're going to use a simple query protocol. Excuse me. Then once you have the connection, you can create a slot, a replication slot. What a slot does is it is a logical view of the database for you. It's a name slot. You name it, you connect to it. You read the changes. Once you've read the changes and you've done something with it, I happen to know one of the companies that's using this in a big way reads all their changes from the database, puts it into a Kafka queue, sends their data to the rest of their infrastructure. So once they've read them and it's into the Kafka queue, then you confirm that you've read them, which allows the server to get rid of them for you. And then you go to read more changes. So back to the top of the loop. Okay? So this is how you create a replication connection. So as we talked about, the URL is just localhost port 5432. The database is Postgres. We set the user. We set the minimum. As I said, you have to set assume minimum server version equals 9.4. You have to set replication equals database. You have to set preferred query mode equals simple. You get the connection, and at that point, you have a connection which is capable of doing replication for you inside the JDBC driver. Okay? The next step is, I said, create a replication slot. You have to name your slot, and you have to give it the plugin. The plugin is a piece of C code which is written and decodes your data in such a way that you can read it. It's a little abstract at the moment, but there are a couple examples out there. In Contrib, there's something called test plugin, and then there's test decode. There's another one called wall2json that's in GitHub, but this is a short version. So basically, in order to create a replication slot, you just call a function called pg_create logical replication slot. You give it the slot name and the plugin name, and now you have a replication slot. The next step in this is to create a stream that you can read the changes from. You use the PG connection that we created that can read replication. You get the replication API. You get a replication stream. You say that you want a logical one. You say the slot name that you mentioned earlier. And then start position is where you want to start reading from, and it starts. Then you can read changes from the database. It's as simple as this. It's a while true. There's a non-blocking message or non-blocking receive message from the stream.read pending. If the message is not equal to null, then you can actually do something with it. In my case, it was printing it. And then the last step here is to confirm that you read it. And it's just set flushed equals, and you tell it what value you've read. The next step was to show you a demo, but again, they wanted to install software on my computer, so the demo is not happening. But any questions about logical replication inside the JDBC driver? I went through that very quickly. There is a real project on my GitHub that actually runs. You can just download it and run it. Yes, sir?
It could be a real fire hose if you're getting everything on the subscription. Can you get just one table, or can you narrow this down any, or are you going to get like everything for the database that you're connected to?
You That's a good question. Do you know if the slot actually allows you to do that?
I mean, I don't think it does, which is why I'm just a little scared.
That would be in the plugin, right?
Right, okay,
The slot itself doesn't do that.
right.
The plugin can do filtering.
So,
Like the logical replication plugin, when you create a publication, does that filtering on the master side.
so the question is, or the problem is, are we going to get all without doing any filtering anywhere, we're going to get all the changes in the database. So imagine if we have, we're Amazon and we're getting all the data from our database and it's, a fire hose, just, dumping data at us. So David asked, is it possible to filter it? The only way to filter it is actually in the plugin. So in the plugin, you would say, I only want changes from table XYZ to come to this particular slot. Okay, does that make sense? I think that's version 11, isn't it, Magnus, where we're going to put in the ability to filter plugins?
The plugins can already filter it.
Well, the plugin could filter it, but I would think it would be interesting if we could just tell it we wanted to only get changes from table XYZ.
Well, again, it depends on the plugin. You could probably use the plugin that comes for standard logical replication intent.
Right.
And just hook into that.
Yep. Any questions about that? Yes?
Yeah, what's the changes look like? I mean, above the bytes, what are they?
They will, okay, so in the example I was going to show you, I would have showed you that, but let me try to explain. You can get the transaction ID, you can get the table, you can get the what happened. Was it an insert, was it a delete, was it an update? You can get the column name, you can get the value. In the case of an update, you can get the value before and the value after. In the case of an insert, you get the value. In the case of delete, I'm not sure what you get. But then how that is prepared for you is up to you in the plugin. In the simple test decoding plugin, it's just a text. It's actually, you have to decode it. In Wall2JSON, it's JSON. And I'm not sure what but how you write the plugin is up to you. But the information.
Altering tables and stuff like that.
Do you get DDL in the plugin? No, there's no DDL.
No DDL. Okay, thanks.
But yes, there is a working example at logicaldecode.git. Please feel free to use it. Send it to your friends, whatever. It's a cool feature. Credit where credit is due. Much of the work on the driver was done by Vladimir Sitnikov, who did a lot of optimization for the driver. At one time, the driver was considerably slower. It's now much faster thanks to him. We changed everything over to Maven. It was done by a guy named Steven Nelson. Rewriting batch statements were done by Jeremy Whiting. And the replication support, also another fellow Russian, Vladimir Gordichuk. I'm not taking credit for any of that work. Question at the back, or no? That's it for me. Any questions? Thank you.